recording. And let's share screens. And there we go. So welcome to big data for today. Last time, well, I guess before talking about last time, apologize to anybody who may have been trying to come to the office hours on Wednesday that I had to cancel those, that my wife was having contractions. We thought the baby might be coming, but false alarm, no baby here yet. But probably means the baby will be coming shortly. So maybe next week we'll be readjusting our schedule based on that. Let's see, I think we have a few other announcements to do. There are 2 new files in this, so I'm just in the week 4 folder right now that we'll probably get to this lecture. So if you want to go ahead and download them to be able to follow along, they're the create food star.sql files. You can go ahead and do that. We're going to see this diff command here in a little bit to help with the homework. This is something that will help with the upcoming homework, the one that's due this week. Everything else that we talked about on Wednesday and are talking about today is about the homework that's due the following week, so about 10 days from now. How is the first homework assignment going for people? Thumbs up, head nods. Okay. Yeah, if you do have questions or anything about that, then today I'll have the office hours like normal. And if you're trying to retake that post-6 quiz, today would be the day to try to do it, either right after class or 1 o'clock is when I have the office hours. And if for whatever reason you can't make today's times for retaking that quiz, and we're planning on doing it on Wednesday, then I'll set up a time with you to redo that sometime next week. So just let me know. Any questions about administrative things on homework or quiz retake? Okay. Maybe one more question for you all is, so a long time ago, passed out this Vim cheat sheet to you all, and you've all had a month or so now of using Vim and maybe getting a little bit more familiar with it. But I'm curious, has anybody actually sat down and tried to memorize the 20, 30 or so commands on this cheat sheet? That was my guess. Normally, or maybe I'll rephrase this as, I've been very tempted to, I've been wanting to have a quiz where it would just be this cheat sheet and all of the commands would be blank and you'd have to fill them in. I haven't done that though because of the baby coming, and it would throw off the schedule of quizzes. So I don't think I'm going to do that. But I do think that it would greatly behoove you to sit down and memorize these commands for a couple of reasons. One of them, the maybe most obvious of them, is that many of you have told me that the previous homeworks have taken you on the order of 10 hours or so per assignment. And if they haven't, maybe they've taken you 5 hours or even more, I don't know. But you're going to be using Vim for another 10 weeks in this class. And so that's on average about 100 more hours per student that you'll be using Vim. And so spending 1 hour of your life memorizing these commands will make those other 100 hours significantly more than 1% more productive. And they'll make them much more enjoyable. So it would be a good use of your time just to go through and try to memorize these commands. Another reason is that when I'm, say, working with somebody, so I mean beyond the scope of this class, but maybe if I were a person giving an interview at a company and I see that the person is using Vim and I see that they're not comfortable using these sorts of shortcuts, then I would be really skeptical of the person. That a good programmer, a good craftsman in any discipline is somebody who is very invested in their tools, learns how to use their tools, and use them well because they use them all the time. And so if I see somebody who's using a tool and not really familiar with it, that makes me skeptical of their ability and makes me not want to hire them or not want to work with them. So maybe a couple of reasons to sit down and just try to memorize these commands. Try to incorporate them into your daily workflow. Another thing, about a quarter of the class has completed that type speed caveat task. So if you recall, there's 2 of these tasks where if you don't complete them, then you'll lose a full letter grade, a full 10% on your final grade in this class. One of those is the culture, reading, viewing. The other one is just making sure that you're a good touch typer. And if for whatever reason you are not a good touch typer at this point in your life, it would be better to work on this at the beginning of the semester rather than at the end of the semester, because typing speed will benefit you throughout the rest of the semester. So there's another one of those things that just being efficient about your life, doing this thing first will make the rest of the class easier. And both of those 2 things maybe don't seem like lazy things to do. They're extra work. But they're lazy in the sense of programmer lazy, of like what Bill Gates values in somebody, or what Larry Wall, he's the inventor of a language called Perl that was like in the 90s, sort of the default web programming language. According to these 2 guys, laziness is the chief programmer of the chief virtue of a programmer. And so we want to cultivate that sort of laziness, doing some upfront work in order to make the rest of your life much easier, where you can be lazy in the rest of your life. Okay, we'll get into, do a quick review of last class's material next. Before we do that, any questions about anything? Okay, then open up the terminal. I have 2 terminal windows open like usual. They're both in this Pagilla Homework 2 folder. I'm going to, let's just make sure our Docker Compose, our Dockers are in a clean environment. So we'll bring it down, bring it back up in the daemon form. And then down here, what we were working on last time was problem 5 in, do I already have it open? Nope. Problem 5 in our homework assignment. And I'm going to move these to be side by side again so that we can see the entirety of the problem in the code. And last time, where we had gotten to was that we had seen 2 different solutions to this particular problem here. The idea is that we have this actors table and this customers table, and our management, for whatever reason, wants to know all of the people who are actors who are not customers, maybe to advertise to them. And we saw 2 different ways of doing this so far. We saw this select statement right here, and we saw how you can use a left join in order to do this. Let's see, make this a little bit maybe more readable, like that, so it fits a little bit better on one line. Over here, to make things a little bit more readable, I'm going to change my prompt over here. Done this in the past, but the way to do it, the PS1 environment variable is what controls our prompt. What we can see equals $ space like this, and now it's just going to be the $ over here is the prompt, ignoring all of this other stuff, not displaying all that. So let's reset this over here. And so let's go ahead and connect to pSQL. I did Control-R to search through my history in the past, and I just typed pSQL, and this command up here came up. And now I can type in any of these commands. In order to be able to copy and paste from Vim again, if I just try to do it like this, it's going to capture all of these numbers. And so I'm going to do :set no number like this. And again, that's :set no number, turns off the numbers. If I delete the no, turns on the numbers, no number. And let's just take a quick look, run this for a second, make sure that no syntax errors or anything, things run, and we're good. let's see. I want to start with we'll go talk about this one here in a second. The two examples that we've done so far again are the first one using the set operations, so the except right here, and then the second one using the left join. These outer joins are sort of what we built up to last time. I want to go through a more maybe in-depth process of checking to see that our solution here is actually the correct solution. So we talked about it intuitively last time, but we never actually ran the checks to make sure that they're correct. And so that's what we'll do next. And we'll see a couple new debugging tools, including this diff tool that I mentioned earlier that you can use while you're doing your assignments. Any questions about where we're at, what our setting is before we do the technical bits? Okay, so in order to, I want to run this code down here, and let's Control D up here. I'm going to, so now it's a little bit hard to tell where I am, because normally I was using like sort of the green prompts to give me an indication that I'm in the Lambda server, but because I did that export PS1, it's no longer a green prompt, it's a black prompt. And so I'm back in the Lambda server right now. I'm going to change this to be in bash. And now let's do /check answers.sh. And so we'd worked on, the other problem we worked on was number 2. We got that to pass. We're working on problem number 5 right now. And problem number 5 is still failing. So we've seen last time, or several times now, the way to check if things are failing or not, or why they're failing, is we can open them up in Vim. So tab E to open up a new tab in Vim. And there's 2 folders that have the information that we're going to look at. The expected folder contains the sort of the test case itself, what we want to have as the output. And then the results folder is the folder that contains not what we want to have, but what we actually got. And we can compare, whoops, there we go. We can compare these 2 things to each other to see why is our result not being the correct one. Why is it not correct? And the first thing to take a look at is the columns up here. That what's expected is that the last name is first, and then the first name is second. So it's a common way to order people's names is by their family names. And I have it reversed over here in my results. Up here in the tab, you can see that it's not displaying the entirety of the name of the file because that'd be too big to fit. But anything that's like part of the path, so results here, expected here, just shows you an abbreviation of those directories so that we can still see that this one is the expected and this one is the results. And again, I'm using the G Shift T to move my tab to the left and G lowercase t to move my tab to the right. So based on this, okay, I had my columns backward. And I can also see that it looks like it's ordered alphabetically by last name and then first name. And so let's go ahead and add those 2 changes. Moving, actually, so save this. I want to rerun this. One last thing to look at on the results here. So I've changed the results file because I reran the check answer script. :E reloads a file. E stands for edit. And there's actually another problem that it had the 3 columns, the customer ID column as well. So YY yank P to paste I dash dash, so we can just look at what we had before. D2W deletes the word and the comma. 2W moving over here, square bracket paste like that. Move the last name or the first name after the last name. $D $, delete to the end of the line like that. And now we have the columns how we want them to be. In order to make the ordering happen, I'm going to press Shift G to take me to the end of the document. Capital A, Shift A to move my cursor to the end of the line, entering insert mode, delete that semicolon, hit enter, and then we need an order by clause with last name, comma, first name like that, semicolon. :W, back over here, up arrow, rerun it, and we'll see that number 5 here is still failing, but hopefully it's not quite as bad. In order to check why it's still failing, GT takes me now, I can see that I'm in the expected tab right here because it starts with an E. I'll do GT again. Now I know I'm in the results tab right here because it starts with an R. And the results tab is, again, the output of actually running my script, running this SQL command. But in order to reload this file again, I type :E down here to reload it. And there we go. Now it's reloaded, and I can compare the two things side by side to see what the problem is. Press G, Shift T to go back and forth. And if we do this, we can see that I don't see any changes between these two files right here. They look exactly the same to me. And so we're going to see a little bit more robust way next of checking the differences between these two files in order to see what the actual problem of our output here is. Down here, I'm going to change our prompt again so that it is not bleeding off the end of the line with the export PS1. So I'll make this a little bit bigger so you can all see it. Export PS1 equals, and then since we're in the container right now, I'll do the hashtag. Again, the hashtag is the standard prompt indicator for when you're root on a shell, and I'm currently root inside of this container right now. See, I'm root at this hashtag right here. So export PS1 as that, and now this is my my prompt indicator, so I can just type things in right here, like echo hello. So let's see, PWD, where am I at? I'm in my Pagilla homework folder, LS. Here's all the things inside of this folder, and the results and the expected are the ones that I'm in particular interested in. And what I'm going to do is I'm going to use this command diff. And this diff command, again, is what's actually being used inside of this check answer script. So on the right over here, :tab E, check answers.sh. And then we can see right here on this line, go ahead and set number so that we can have a line number, line 13 right here. It's running the diff command to actually check if these two files are the same or not. And so I can reproduce that command down here, diff with expected /05.sql results /05. Not .sql, .out. There we go. These are the two files that are being compared, and these are two files that I have opened up here. Previously, I was looking at them manually to see what the difference is, but I'm lazy and I am a fallible human, and so I'm going to trust my computer to do that better than I can do it. And so here is the output of this diff program. These, and we call the output of this program a diff. So this right here is the diff between this file and this file. And these diffs are things that are super common to see. If you've explored around like GitHub in the interface, you've probably encountered these diffs at different points. But what they're showing me is the difference between these two files. The way to read this is up here when it has the line numbers, or what these numbers are, they are line numbers. This first number is the line number in this file to the left, and the second number is the line number in this file to the right. The A right here stands for added. It means that this line right here, was added to the file. And then down here we have 202, C203. 202, again, line number in this file. C stands for change, and then 203, line number in the file over here. So the numbers left corresponds to left, right corresponds to right. A for change, A for add, C for change, and also D for delete. Nobody actually looks at these letters though. Instead, what they look at is these little less than, greater than signs. The greater than sign means that this was added. The less than sign means this was taken away and this was added. So this right here is just at the very end of all of our outputs. Shift G to take me to the end of the line. It tells me how many rows were returned. And we can see because our output has one more row than it should have, we're getting 200 rows down here. G, Shift T, take me to the expected. Shift G down to the bottom, 199 rows down here. So using this diff command, I was able to see exactly what is the lines that are different between these two files. And now I can use this to try to figure out what the problem was. In this case, what the problem is that when I'm doing this left join, in order to, let's see, illustrate this again, I'll go back to this command right here, what we had previously, re-enter pSQL over here, and copy this command into pSQL. We had this customer ID column, and the customer ID column is only has a value when the particular actor exists in the customer table. So Jennifer Davis is the one person who is both an actor and a customer of the store. And so this is the one row that we actually wanted to remove. All the other rows in the actor table should stay there. And the way we should be doing that is with a where clause where customer ID is null, like that. Colon W, not colon shift W. And this removes Jennifer Davis because Jennifer Davis's customer ID is not null. In order to make this command actually work, be what the problem's asking for, we do select last name, comma first name like this. We can have our where include columns that are not in this select list like this. That's perfectly okay. So this won't result in any sort of error. Q over here to get out of the pager environment. These environments over here where you can scroll up and down are called pager environments. Q to get out, Control D to leave pSQL, up arrow, up arrow, up arrow, till I get back to my check answer script, hit enter. And now finally, problem number 5 is passing. A lot of things happened there. Any questions about any of that? Does that all make sense? It's all a blur. People nodding their heads when I said it made sense. Nobody reacting when I said it was a blur. Yes, question.
What if customer ID, I don't know, didn't exist and we still have to take only the first and last name to appear in just one, just the actor table and not in the customer table?
Yeah, so here on this second solution, I was, with this left join, I was using this customer ID, checking to see if it's null. The question is, what if there was no particular column like that I could do to check to see if something's null? And the answer is that this first solution up here will, is able to take advantage of that. That this first solution, again, is a little bit more explicit, says select everything from actor except down here, inner join actor on customer. So all of the rows in this table that match each other like this. So this solution right here would work if there was no column that you could check to see if it's null. Let's go ahead and try this solution, see if it actually does work. I'm going to do up arrow, do the /checkanswers.sh like this. And we'll see that it is failing. And let's just check why is it failing real quick. So I'm in the results tab right here, :E to reload it. Lambda server is being laggy. There we go. And we can see that the column order is incorrect and the sorting is incorrect. So I'm going to do 1 GT to jump all the way over to the first tab, 1 GT to move to tab number 1, 3 GT moves me to tab number 3, 1 GT back to tab number 1, and change this so that it's, I'm going to do D2W A comma first underscore name like this, escape : W. So that changed the ordering of my select columns right here. And now I want to get down to this line right here and add my sorting. I could use the down arrow. Oh, that's so many key presses. That hurts my fingers. Instead, I'll press shift in the curly brace, which takes me to the end of the paragraph. So much nicer. And then I'm not in insert mode right now. I could do I to enter insert mode and then type stuff in like this, but it kind of is a little bit ugly to me to not have a blank line between the two problem solutions. So escape U, undo, and I'll press shift O to take me into insert mode, adding a new line at the same time. Type where, sorry, not where, we want an order by. Order by last underscore name, comma, first underscore name, semicolon. And now we have this other semicolon up here that we have to get rid of. We'll just do an up arrow, shift A, delete to get rid of it. : W, save that. Back over to left-hand terminal, run the checkanswers.sh script, and we see that it's still failing. Back over onto the right-hand side, escape, GT, move over here, :E to reload this. It looks pretty good to me. G, Shift T, GG moves me to the top of the screen so that I can compare these two things. Both of these files seem like exactly the same thing again. And so now we have to figure out why are they different. So we'll return to our trusty diff command, Control R to bring up my reverse search, DIFF to bring back that diff command, hit enter, and here's the results. We can see that line 48 is incorrect. Line 48 here, so this is taking away Davis Susan, adding Davis Jennifer. And so what's going on here? I'm going to reopen up pSQL and paste this command into pSQL. Like that. Shift G to jump down to the end. So up here, I have two select statements. Up at the top, I have last name, comma, first name. Down here, I have first name, comma, last name. So when I did my accept, it pays attention to the ordering of these columns right here. And so one disadvantage, one reason why people who are more experienced with SQL do not like using these set operations is because you have to put the column names in multiple locations, and it's easy to have bugs like this. And what I should be doing is having the last name first. So find comma, D, $, capital F space, P to paste, A comma, shift comma, X, like that. So now we have last name comma, first name, last name comma, first name. Now the things match. Control D, up arrow, rerun my check answers. Still failing, number 5 right here. Rerun my diff command like this. And now we can see that the previous, we're off by 1 number of rows. If I type pSQL right here, copy and paste this whole command in here. Shift G, take me to the bottom. We see that we get 198 rows as the results. Over here on the right, GT in the expected 05.out. Shift G, take me to the bottom. We should be getting 199 rows. GT onto the results, 05.out. This is should be the same as this thing over here. Shift G to the bottom, 198 rows. Why are we not getting all of the rows? The answer is because there's duplicate rows in the actor table. Turns out there are 2 actresses named Susan Davis. And whenever we use one of these set operations, again, it treats this entire thing as a set. Sets are not allowed to have duplicates, and so it removes duplicates. Anytime you want to keep duplicates when you're using set operations, you have to add the all keyword after whatever the set operation is. So last time we looked at union versus union all. This is except versus except all. Except is like everything up here minus this stuff down here, everything here except this, but it's a little bit tricky because except will remove duplicates. And so you have to add the all here to not remove duplicates. Escape :W, over here Q, get out of the pager, up arrow, oh, still in pSQL right here, Control D to get out of pSQL, Control R, / check answers. The / was enough to take me back to check answers, hit enter. And now once again, we're passing on problem number 5 right here. So now this is actually a correct solution equivalent to what we have down below. The 2 caveats that we had to check were that the column names right here were not correct. When we have these set operations, we'll have multiple select statements. We have to make sure all of the column names are matching each other. And then the other problem, which happens a lot, is that if you're using these set operations, you almost always want to add the all at the end so that you're not removing duplicates. I don't think in my life I've ever had a situation where I wanted to remove the duplicates. So I always just by default add the all. Any questions about this problem? Are we tracking? Is that all good? Head nods? Yes.
Not in operator is like except operator is like thing.
Your question is about not in?
Yeah.
Yeah, so the last time on Wednesday, we were motivated this left join with this idea of a not in operator and said that left join can always be implemented as a not in or as a set operation like this except. So the except is not equivalent to a not in. Except only works when you're combining select statements like this. But we can solve this problem with a not in operator. And so that's what we'll do next. A third solution to this problem using the not in operator. Shift D, take me to the bottom. And I need to select last name, comma, first name from actor, where. And let's try, we'll see the syntax that we've seen before, and then we'll introduce something new. So last name, not in, select last name from customer, like this. Let's add our order by last name, comma, first name. So this is almost the same as these two commands up here. The difference is that this not in operator is only looking at the last name. And what we really want to do, like what this except was doing, is it was removing things that match not just the last name, but match both last name and first name. And so here in this select clause, what we're taking from the customer, we need to change it to not just last name, but last name, comma, first name, like this. I'm going to reformat this just a little bit to make it fit for our narrow screen width. In order to get my cursor to the parenthesis over right here, I'm going to type Shift F for find, and then parenthesis going backwards, and A, enter. Oops. There we go. I wanted to keep that. And dent that. F, $sign. There we go. So that's a little bit maybe nicer formatted for a smaller screen. But here I'm taking two columns over here, and I only have one column over here, so that's not going to type check. We're going to get an error message. Open up pSQL, and let's copy and paste this command over here, hit enter. We get subquery has too many columns. The stuff inside parentheses, again, is the subquery. There's two columns right here, only one column right here. In order to be able to search on multiple columns in a subquery, we have to do this. Put it in parentheses and separate the columns by commas. In general, anytime in SQL you have parentheses with commas inside of them, this is going to be basically like a row. So looking for any row that has last name, comma, first name that matches inside of a customer. And so now that query, we'll go ahead and run it, is going to be the same as the queries we have above. Control D, up arrow, check answers, and there we go. Number 5 is once again passing with this query right here. So the except, not exactly the same as not in because they're just syntactically doing different things, but you can implement one with the other. So they're very closely related concepts. Any questions on that? The main thing that we introduced here is this new syntax for multiple columns with subqueries.
Why is that not automatically included though?
Why is what not intuitive?
You have to like put all the columns which are doing in the subquery and not.
Yeah, so I mean, it is sort of intuitive. There's maybe like different syntaxes that we might try to do, something like this. That's not going to work. But it also like doesn't matter what order that you put things in here. I might do something, it doesn't really make semantic sense in this case, but there could be other situations where I might want to have the columns like not actually match what the columns are over here. So yeah, you're right that it makes sense that I would say the type of the thing to the left of the not in has to match the type of the thing to the right of the not in. But they don't have to be like exactly identical. Any other questions about these problems?
So the except clause cares more about long order about not in.
So both of these care about column order. This is syntactically correct, but it is semantically wrong. If I do this, to enter no errors here, Shift G, we're still getting all the rows that we're not eliminating anything. So this is the same thing that I was getting right here as up here when I forgot to switch these things around. So it does matter what order you put things in. It's just not a type error if you put them in the wrong order. You do that. Maybe, well, I'm here. So you notice that I press the U. It's like 5 U presses. Wow, that's way too many. If I press Shift U, it undoes everything on the line. In this case, that goes a little bit too far. So I guess I do have to press the little U. But Shift U can do like an unlimited number of undos limited to that line until you change to a different line. Colon, escape, colon, W, save, colon, Q. If I want to quit out of all my tabs at once, I can do QA for quit all, and it leaves all the tabs at once. Everything we've covered now takes us up through, SQL up through problem number 8. Problem number 6 here has 2 different forms, 6 and 6b, because one of these is specifically asking you to use a left join, and one of them is specifically asking you to use the not in operator. All of the other ones, you're free to select whichever method makes the most sense to you. And again, in about a week from now, we'll start with the performance implications of all these things, and we'll see that sometimes one of these methods might be more performant than another. Okay, we're going to go on to next is the last topic that we need for our homework 2. And all the way down at the bottom here, this is arrays. And arrays are, yeah, I guess, again, next week we'll talk about like why, the why of arrays. The thing to focus about on this week is just like the what of arrays, the syntax for getting something done. And so in order to use arrays, this is where the Q, Control D, LS, these 2 create food tables come into play. On the right over here, I'm going to do vim create food. We'll start with the array version, array.sql like this. Up here on line 4, this is the syntax indicating that the thing, this item right here is an array, the square brackets like this. And if I open up, well, let's see, let's first do, let's load this file into pSQL create food array like this, and hit enter. Creates the table, inserts the values. Now let's run pSQL and we'll do \d on food. And so we have flavors right here as the name of the column, and then text array as the type. And if I press Q and do a select star from food, then under flavors here, you can see that each one of these different foods has multiple different flavors associated with it. So bananas are sweet and they're soft. Maybe you might complain that soft is not a flavor, but that's a semantic issue, not a syntactic issue. So semantically, my flavors column is a very broad definition of flavors. Celery has no actual flavor, it just has the crunchy texture. Carrots are sweet and crunchy, pretzels, salty, crunchy, bready, and so on. On the right over here, you can see there's a few different syntaxes for inserting arrays. And most of these things, like, I mean, you might not have come up with this on your own, but you can probably read it and guess what's going on, that there's 2 different elements in this array. This one over here, though, is one that I find every time I look at it to be extremely ugly, because it's yet another like way that quotation marks in SQL are weird. This outer quotation mark indicates that the thing inside is technically a string, but it will automatically get cast into an array because it's being inserted into an array spot. And then we have these curly braces that are required. And then inside of here, it's double quotes to indicate that these are the contents of the 2 entries of the array. So normally when we're using the square bracket notation, single quotes to talk about like values, but inside of this weird array notation, it's double quotes to indicate values. I don't know why they chose to do that, but that's what they chose to do, and we have to live with it. If you have an empty array, you must cast it to tell it what like things are going inside of it, unless you do it this way, in which case it's automatically done. There's a number of many array functions, all the ones that you're familiar with from like Python or C++. You can index into arrays, you can do whatever you want. But none of those standard like programming array functions are things that you want to use. They are all asymptotically inefficient and constant factor inefficient. So what you want to use is there's this function unnest. So we just did select star from food. Let me go ahead and make this a little bit nicer. We'll do select name, comma, flavors from food like this. And then what if I want to, well, our motivating example is going to be, what if I want to get all of the foods that are sweet? How can I get all of the foods that are sweet? Here, so what should the answer be? We have banana and we have carrots, and that's it. If I can't do something like where flavors equals sweet, this doesn't work, just syntactically invalid. There's, again, array operations that we could do to try to do something like this, but that's going to make things be inefficient once we start talking about that. So instead, what we're going to do is we're going to do unnest of flavors like this. What the unnest function does, so we'll see it here in a second, what the unnest function does is for every entry in this array, it'll create a new row in the output where the flavors column is replaced by that entry in the array. So we'll have a banana sweet and a banana soft. We'll have a celery crunchy, and there will be only one celery row because there's only one entry in the array. There'll be two banana rows because there's two entries in the array over here. And then the water and the vitamin pills, because there's no entries in the array over here, they won't exist at all. So I'll hit enter. This is what we get, just so that we can compare it to what we had before. I want to bring them both up on the same. There we go. So two banana rows, because there's two entries over here. One celery row, because there's one entry over here. Two carrot rows, because there's two entries over here. And if I want to actually now find all of the things that were sweet, all the foods that are sweet, I'll do unnest flavors as flavor, give it a name. I'm gonna move these things sideways so that we can see this without it bleeding over the edge of the terminal. Select name unnest flavors as flavors from food. Just hit enter real quick, and let's go back to vertical for a second. So previously, if you were paying particular attention, you might have noticed that this column's previous name was unnest. Whenever you have a column that is has a function application inside of it, so here we have a function application without a column name. The name of the column will just be the name of the function. Unnest is kind of not a super nice thing to work with though. So I named it as flavor right here, where name is flavor. And now what I'm going to do, so here's the query. Let's do \e so I can do this inside of Vim. And so I'm going to make a subquery out of this. I'll do a select star from this whole thing, where flavor equals sweet, like that. Escape : WQ. Uh-oh. And I always forget to \E, come back in here. I always forget to name my subqueries. Like that. So anytime you have a subquery in the place where a table can be, so like in the from clause, any place where you can refer to this table somewhere else, you have to name it. So that's just what this T right here is doing, giving it a name. Default name, easy to type, T for table. Save this. And now we're getting all of the fruits that are sweet. So that's the way to access things that are defined inside of an array, is that you use the unnest function to convert it from an array into a table, and then use that table as a subquery and the where clause on the subquery. Questions? Joey.
So in arrays, do all of the things inside that array have to be of the same type?
Question is, do all the things inside of an array have to be of the same type? And the answer is yes, that here, so like in Python, there's no check to see that everything's of the same type. In Postgres, everything must be of the same type, and that type is whatever is declared right here. There will be significant performance implications based on what particular type is chosen here. So we'll get to that next week. But yeah, that'll be important. Question?
Like, why do you use this software? Like, can you not just use like flavor, like where flavor from that same place?
Yeah, question is, why did we have to use a subquery? Could we do something like where flavor equals sweet, like this? And I'll try that. And the column flavor does not exist is our error message right here. Even though I'm defining it right here saying, yes, please let there be a column flavor, we can't refer to the output of this unnest function inside of the same column or inside of the same query. Yeah, we could, like, obviously this is like, should be the same thing as what we had written before. And we could imagine a different version of SQL where this is just like syntactic sugar over the subquery, but that's just what the syntax is that it has to be a subquery if you're filtering on an unnest function. Good question. Any other questions? Okay. Then I want to take a look at, to help maybe illustrate a little bit more about exactly what's going on with these arrays and how they compare to all the join stuff that we've been working on. Is this create food normalized.sql. So down here in the bottom colon tab E, create food underscore normalized.sql. And let's adjust this a little bit side by side. So the only difference between create food normalized and create food array, they store the exact same information. They're just storing it in two different ways. So up here we have a food table. And in this food table, we have our food ID and name, similar to what we had before. I guess I just call it ID here, name, but these two columns are semantically the same as these two columns right here. And then anytime you have an array, one of the things that you can do is you can sort of factor out that array into another table. And that process of factoring out arrays into a table or somehow like factorizing things in SQL is called normalization. So we factored out the flavors array into the flavor table down here. And now down here in this flavor table, there's a flavor ID, a food ID, and a name. This flavor ID is, I guess every table just has its own ID as a traditional thing where it's an int and a primary key. And then the food ID right here references this food ID, and then we have a name. So down here we have something like sweet and soft. Both have, this is the food ID. Food ID is the second column. So food ID right here, sweet and soft, both correspond to banana. And if we do an inner join on this flavor table and this food table, we'll get the same result as the unnest table. So to illustrate that, let's go ahead and load up this pSQL create food normalized table. We get this error right here saying the relation food already exists. And so that's because there's a name clash between create table food and create table food. And so what I'm going to do is I'm just going to destroy my database. Docker compose down. One of the nice things about Docker is that we can just, anytime we want to reset our database, it's super easy to do. Docker compose up -d. Don't have to rebuild anything, just bring it down and bring it back up. That resets the database back to its original state. And now if I type the pSQL create food normalized and move it on to one line so we can all see it. This is the same command that I typed before that errored out because of the name clash, but now it all works just fine. And so now if I type pSQL up here, I can do something like select star from food and select star from flavor, like that, and it all works nicely. So in order to illustrate now that same result, we'll just interjoin the flavor and the food tables. So select star from food, join flavor, and we'll join it on the column of food ID. Choosing food ID because, so food ID right inside of flavor corresponds to the food ID inside of the food table. Using food ID like that, hit enter. And let's side by side again. We have our food ID, our flavor ID, and our names. So we have our 2 bananas with sweet and soft, our celery with crunchy, our carrot, sweet and crunchy. Same things that we had before. And so now to find all of the sweet foods, I just add a where. So now this column over here is called name. This is the one that I want to reference. That name is the flavor name. So where flavor.name equals sweet like that, and we get our banana carrots, sweets. So banana carrots and carrots are the only sweet foods. I wanted to maybe make it a little bit nicer. We can do food.name, only selecting the name of the foods like that. So in general, anytime you have an array, you can re-represent that as this foo, or as by breaking it off into another table and then using an inner join to emulate that unnest function. Unnest is basically like an inner join. Any questions about that? Has everything today just been, oh yeah.
I was wondering, like, with the join statement, they like double like the bananas and like is that something that it might kind of...
So question over here is, like, in the food table we only had 1 banana, but over here in the join we have 2 bananas, and exactly what's going on. And the thing to always remember about every sort of join is every join is syntactic sugar over the cross join. So let's go like this, vertical again, sideways, and we'll do select star from food, comma, flavor. So the cross join between food and flavor, hit enter, and recall that the cross join, we have every row, so food ID 1, banana, every row from the leftmost table combined with every row from the rightmost table. So sweet, soft, crunchy, and so on. And then what the inner join does is with your join condition, so I used the using keyword before, we'll use on this time. The join condition is just like a where clause. So on food.food ID equals flavor.food ID. And, whoops. Because the cross join, it is the actual where clause. This is our result. We now no longer have 10 bananas. We have 2 bananas, sweet and soft, because only sweet and soft corresponded to the bananas. If I take away that where clause, then we can see that the sweet and soft right here both have food ID of 1, food ID of 1, but then all these other ones have different food IDs, and so they don't match, and so they don't get included with the where clause. So this is the verbose, non-syntactic sugar way of doing an inner join. The nicer way of doing an inner join is doing food join flavor and changing the where to an on like that. Same exact results, just slightly different syntax. And then we also have further this, this using syntactic sugar, which lets us, anytime we're doing an equality comparison on two columns of the same name, common thing to do, we can use the using clause instead, and that gives us the same results. Same results modulo, or up to the number of columns. Make it a little bit smaller. Here you can see that the food ID column is duplicated. Food ID column is duplicated when I use the on syntax. When I use the using syntax, since I'm joining on the food ID, it only has one food ID here. It knows that all the other food ID columns must be the same, and so it doesn't duplicate them. Here, our condition happens to guarantee that all the food ID columns will be the same, but SQL doesn't inspect the condition. It just, and so it duplicates those food ID columns. But otherwise, it's exactly the same results. Last time on Wednesday, I got a little bit ahead of myself talking about the natural join as well. And the natural join in the example I started doing didn't work out super well. So I'll do a better explanation of the natural join right now and explain why it didn't work out last time. The natural join is just syntactic sugar for the using clause. That with the using clause, I have to know exactly the name of the columns that I'm joining over. A natural join, no using clause, just say natural join like that. Oh dear. And it's not working. And I fell into the same trap again. Okay, so what natural join does is it automatically selects the columns for you that you should put here in the using clause. And the way it does that is it just uses all of the columns of the same name. In this case, the food ID is the same name in both of these two tables. Food ID is the same name, but we also have this other column named name, which is the same name. And in my tests, I had this one named flavor down here, so it was different and it worked. But because it's named name and not flavor, these two columns match and it joins on both the names being the same and the food IDs being the same. There are no columns, no rows down here that share the same name and food ID, so that's why we're getting 0 results. I'm gonna real quickly change line 21, GG, go over here, CE, flavor, CE, delete the word, enter insert mode. Like that, come down here, Control D, and exit out of this. We'll do our Docker compose down. Up dash D. Back into bash. Re-psql, create, food, normalized, like this. Everything's added again. Now into psql. Now we'll do the select star from food, natural, join, flavor, and we get the same results that we had before. So the natural join is syntactic sugar over the using clause, where the columns in the using clause are automatically determined for us based on the column names. Most people don't like using the natural join because of these issues where, like, if column names aren't exactly what you thought they were, then you're going to get weird results. And so based on the principle of this idea of explicit is better than implicit, most people will not use natural joins. I personally never use them, always use the using clause. But again, so the natural join, it's confusingly named. It's not a separate type of join. So like the inner, left, right, full join, all of those can be natural joins. We could have a natural left join, that's perfectly okay. it's what it is it's syntactic sugar over the using clause, just like using is syntactic sugar over the on clause. Your handout that I gave you last time goes through a bunch of weird edge cases for all of these different joins that will really test your knowledge of them. And so I recommend using that to as like your study guide to make sure you understand these joins. But all this material that we've covered today and Wednesday, this is what you need for your second homework assignment, the Pagilla Homework 2, and not for the first homework assignment, which is due this Sunday. We've also at this point covered everything that you need for Pagilla Homework 2. So if you want, you can get started on that. But on next class period, we will do an example of one of these unnest functions in the homework assignment with the Pagilla database. Any questions about anything? Okay, we're a few minutes early, but we'll go ahead and call this the end of class, and I'll happy to stick around and answer any questions that people have. Or again, office hours at 1, and reminder, if you're hoping to retake that POSIX quiz, then please try to do it today. Otherwise, get in touch with me and we'll schedule a time that you can do it.
Yeah.
And I hope you all have a great weekend.